Professor Wojciech Adamczyk. So please take the floor is yours, and thank you very much.
Okay, I hope that you are able to hear me. Thank you for introduction. I very welcome you at this session. Yep. We need to wait a few minutes for the presentation. I was asked to give you some short lecture, opening lecture, about application of some numerical techniques for medicine and for development some artificial models that can be used in practical applications for valve treatment and for aortic valve procedures. So when we are starting doing any model application, we are thinking about developing some numerical model. We always need to think about the limitations of the model, and we need to remember that always all models are wrong and only some of them are useful, which means that each of the models, first of all, need to be tested and validated in some conditions that can give you any perspective whether any model or this model what you are trying to develop is in applicable range or expectation range. It cannot be applied for any kinds of applications before we will not perform the validations. So generally, when we are doing such stuff like that and we are developing model, we need to think about new approach which is in silico applications. And in silico, this is the combinations of in vivo and in vitro experiments that combine everything together, while the simulations and the prototyping process is performed using our computers. So generally in silico, which means that we are using computers for development and testing models. Of course, in that case, if you are talking about the validations, we need to take into account real data, and these real data always come from the in vitro and in vivo experiments, which are the sources of the data which can be used for that purpose. So generally, when we are trying to use computer models, numerical models for simulations of the reality or any kind of problems, we are talking about some shortcut like CFD, which can be interpreted in different way depending on the situation when you are. Some funny extension of the abbreviation, the colorful fluid dynamics or colorful directors. Of course, this is only the simplifications, but when we have the model and the model will be developed and tested, validated using the experimental data or lab data, then we can talk about the computational fluid dynamics, which means that we have the model that can be used for modeling reality and real case. Without this validation stage, we are talking only about nice colors and nice data, which sometimes is completely not applicable for anything, and this need to be changed. So when we are talking about numerical techniques for the cardiovascular system, we already need to remember about the limitations of the models and some efforts that need to be put into the model development before it can be applied. So generally, when we have a vascular system, we need to deal with a lot of veins, small veins, sometimes very difficult to model, and we need to use some simplification like the porous medium or some mathematical models which are simplifying the approach which is used to simulating blood flow. We need to remember that the flow generally, due to our heart functionality, is pulsative flow, which means that we need to deal always with the transient state. So we cannot perform simulation in steady state, which which provides some additional difficulties into our simulations. Before then, we need to extend our simulation for limited time, which in some cases where the geometry and the model is very huge and consider a lot of numerical equations, numerical models, or the numerical cells, it's time consuming and challenging. Always when we are dealing with, for instance, coronary arteries, we need to remember that they are put, for instance, on our heart, which is the muscle, which acts, which deform during action, during the working conditions. and those vessels always are movable, which depends on the heart cycle, the flow rate, and pressure, which is generated by our heart. So this also need to be taken into account. Also, other radiological features of the blood need to be taken into account. For instance, for red blood cells or white blood cells, where we need blood flow cells, where we need to take into account the appropriate equation model, which can be used for such approach. The question is whether we somehow have possibility to combine everything, to combine simulations, to combine machine learning, CFD simulations, multi-stage validation in order to develop some new approach which can be useful for physicians, for doctors. So the idea which are working now in our team is the application of artificial intelligence, machine learning for development some diagnostic tools which can be used for aortic diseases. So generally, when we have a problem with aortic valve stenosis, we need to deal with implantation of the valve, and we have different techniques that can be used for implantation of valve. We have the biological valves, or we have the mechanical one. The mechanical are mostly well validated, while the biological still require a lot of efforts and development of new approaches. So we can imagine that in order to develop the techniques that can be used for the treatment of the patients, we need to have appropriate range of data. So we need to have retrospective data that can be combined with in vivo and in silico simulations. So generally we are collecting the retrospective patient data where we have all information about the implementation of the aortic valve. We have the numerical model, the simulation, the CFD simulation, when we are able to simulate the flow through to the valve and the interaction of the fluid, the blood with the valve leaflets, and give the response about the possible interaction between them and possible kinetic energy generation, which can affect the thrombus formations. In the same way, we need to collect the data in the laboratory, so we need to have in vitro data, which can be used for checking the functionality of the valve new construction, which can be implemented into the problematic patient. When everything collected together, we can create the data repository. So before we start doing machine learning, artificial intelligence, and development new fast and robust model, we need to combine everything in the repository. Based on that, we are able to go one step further and start preparation of the models. So based on the collected data from the laboratory, from the simulations, and using the retrospective data of the patients, we are able to connect everything and develop artificial models which can be used for real application. So generally, depending on the parameters that we are looking for in our simulation, we can collect the different parameters like the pressure, coronary height, valve sinus, etc., which can be used as the output of the model, which give some idea about the valve implantation into the problematic section. So if we will have such a model, such a development technique, then we can think how we can implement this in reality. So we can imagine the situation that there is the patient which has the problem. There is the physician which are making the diagnosis, and the diagnosis is that there is the problem with the valve. So when the application, when the device or the tools will be developed like that, like presented here, then the physician are able to ask the model, the developed system, the tool, what the doctor is supposed to do. And forming appropriate questions to the system, he can receive response about the best configuration of the valve for given patient, configuration, real data, because we always need to take into account that each of us is different and we need to somehow deal with this. Of course, there are some interpolation, approximation techniques that need to be applied for that in order to find appropriate relations between the anatomy of the patients and selected valve, as well as the place when the valve can be implemented. So before we can do this, we of course need to perform a lot of experiments in our laboratory, or any kind of laboratory. It's depending on the application. Here you can see the testing of the mechanical valve and how does the valve looks like with the comparison with the simulation data. So that is one case which can be used for testing of the valve. Of course, when we are talking about the biological valve 3D models, when we have the leaflets are deformables and also movables, then we need to provide more sophisticated techniques which can allow us to perform the simulation, to visualize the flow around the valve and extract the necessary data which can be used for supporting artificial model development or using the machine learning techniques. This is the example of the in vitro experiments in our laboratory, in our department. You are able to see the valve holder where the valve can be placed, the biological one. And based on the configuration of the test rig, we are able to observe the opening and closing process of the valve leaflets. And based on that, we are able to calculate the lumen, which can be also used as the parameter, which can be used for testing the valve, and also different configuration, different functionality can be set up on the test rig to test the valve functionality. Of course, there is also important things that the testing, the new product, the valve in the environmental, more or less closer to our anatomy. So in cooperation with the American Heart of Poland and the Research Development Center, we are doing some implantation of the valve in the ONI model in order to get the medical data, which also can be used for supporting new valve development and implantation in the future. So to make some quick summary, we believe that putting a lot of effort into the development stage of the model validation process and experimental work, we are able to build a tool that finally will be able to support physician or cardiologist in selection appropriate valve configuration for given patient anatomy. Of course, this will take a while in order to perform all the data, but we are working on that. And we believe that in the near future, you will be able to perform such, to demonstrate the functionality of such a diagnostic tool. So thank you.
Presentation. And before we start, I have a small announcement for you because we have 24 presentations. So each one will take 2 minutes and 30 seconds. So it's almost 3 minutes thesis. And you are welcome to scan some kind of code query. I'm not sure that they will be given to you, and you can choose your favorite, the best poster presentation. So it's only one shot. So thank you for your attention, and I think we can start. So the first one is the Miss Beata Sobotnicka.
Hello everyone, my name is Ewelina Sobotnicka. I represent Łukasiewicz Research Network, Krakow Institute of Technology. Today I will be presenting our research, which aim of the study was to develop approach to a new methodology for assessing psychophysical performance in early old age. In Poland, the population over 65 is expected to grow by 74%, which may lead to an increase in neurodegenerative disease such as dementia and Parkinson's. In our work, we analyze data 294 data. We divided data into 3 groups. A control group, a group with mild cognitive impairment, and a group with dementia. We use AI methods, including neural networks and nonlinear model, such as SVM and random forest for analyzing data. As a result, we identify SVM model is the best for analyzing geriatric data. two tests which had a high predictive value, MOCA and clock driving test, key predictive factors such as history of myocardial infarction, vitamin D3 levels, and BMI. And finally, an additional tool in predicting neurodegenerative disorder may be the assessment of the biological age of the cardiovascular system. Thank you for your attention.
So the next one is Mr. Mateusz Pawlik with the two of the presentations. So you've got 5 minutes for two.
Thank you. Hello everyone, I'm Mateusz Pawlik and I would like to present you first poster which was made in cooperation with University of Bucharest, Faculty of Veterinary Medicine in Bucharest, and the Department of Surgery and Anesthesiology of Small Cats, zygomatic arch fractures in cat. Why cats, not the dogs? The matter is simple. Every single cat is almost the same. When you take a European short-haired cat or European long-haired cat, every single skeleton is almost the same, around 4 kilo of weight. In dogs, situation is a bit more complicated because the dog as a species is the most pincher from 2 kilos up to big dogs, big breed dogs like Tosa Inu of 90 kilo. So, in University of Bucharest, they have almost the biggest hospital in veterinary field in Europe, and they are facing a lot of zygomatic arch fractures in cats. The problem is that there is no anatomical plate for securing such fractures. So the idea of the poster, the idea of the study was to develop a universal plate as it's used in human medicine. So anatomically shaped plates for treating the craniomaxillofacial fractures in cats. Here we can see the sample of the fracture. On the basis of 40 CT scans of healthy cats, we have designed universal skull of the cat, male and female feline patient, and on the basis of 0.0 diameter thread, bridging plate of 4 screws 2.0 thread, and extended bridging plate of 6 locking screws 2.0 thread. Those plates were made from titanium alloy in a certified ISO process to provide the same standard for veterinary medicine as it's used in human medicine. On the basis of initial 3D printed plastic polymeric samples, then titanium alloy samples were used and machined using CNC machining for providing threaded socket for locking screw system. The next step of the study will be the cadaveric tests on real-life specimens, and the next step will be the implantation in real-life scenarios, as almost 15% of fractures in cats are related to craniomaxillofacial. In most of craniomaxillofacial fractures in cats, there is parallel fracture of zygomatic arch. So it's a first type of a plate. Thank you. Surprisingly, I have the second poster, but this particular one was a joint cooperation between Department of Biomedical Engineering here, Department of Veterinary Science, University of Turin, which is represented by Luca Manassero sitting at the audience, Clinica Veterinaria Vezzoni Cremona, Italy, Department of Surgery and Anesthesiology of Small Animals, Faculty of Veterinary Medicine, Warsaw University of Life Science in Warsaw, and KBMD. Surgical training. When we have real-life species, we can do the training on real-life scenarios. But when there is a need for some specific deformity, it's a bit complicated to have 20 patients of the same size, of the same deformity. In dogs, in veterinary medicine, when the anatomy is a bit more complicated from small to giant species, we have even more complicated situation. So when we need, for example, the uniapical deformity of forearm in giant breed dog, we can probably find one patient. But if we would like to do the surgical training, we need at least 20 copies. So then 3D printing of the deformities. The aim of the study was to design and develop anatomically precise 3D printed models of the canine antebrachium for use in a specialized workshops. The workshops were related to corrective osteotomies of antebrachium on the basis of CT. The easy one was the one planar deformity of radius bone. The moderate one was two planar deformity with torsion, and the hardest one was a multiplanar deformity with multi-points of center of rotation and angulation. On a basis of 3D CT scans, we have developed 3D model. Then cortical shell was simulated with thickness of 2.5 millimeter. Then cancellous bone inside as a spatial mesh of beams with 1 millimeter diameter and porosity of 0.8 up to 1.2 millimeters. Then there was a design of flexible connections for the models. And then models were printed using DLP technology, using custom-made meta-acrylate-based resin manufactured by Cabiomede. After printing, models were post-processed, and then they were sent to Cremona in Italy for the workshops. Those models were first models of this kind manufactured by our company, used in advanced workshops of corrective osteotomies. So Izarov apparatus workshops. Surprisingly, models, 3D printed models with cortical shell designed in a bit specific way provide better accuracy of screw holding power than shin bones, soft bones, and other bones available in the market. So since that time, we are developing those models for other types of deformities to be used in other types of workshops, not only deformities, but also other types of orthopedic conditions. Thank you.
Dear audience, let me introduce myself. My name is Michał Tomaszewski, and I'm from Military University of Technology. I would like to present the result of our work. The aim of the study was to perform modeling blood flow through middle cerebral artery with simplification on boundary condition. As you can see from the above graphic, the first step was to perform a CT scan of the brain sample. After we develop a flow domain, the flow domain consists a lot of branches. These branches is not visible in standard medical CT scan. And after this model development, we use porosity regions to simulate flow. The flow was simulated in ANSYS Fluent software using computational fluid dynamic. As a result of the transient analysis, we obtain a wall shear stress divergence map and time of average wall shear stress. And these parameters help identify areas prone to the deposition of the harmful substances, such as lipids. On this graphic, you can see the highest value and the lowest value, and the area which can be dangerous. Thank you very much for the attention.
Good afternoon, everyone. My name is Szymon Saturnus, and I would love to show you the short view of our work, which aim was to compare the bone tissue model reconstruction process using the CT scans and MRA. First of all, we've made a CT and MRI imaging. Then we made a comparison of the characteristics of the images. Next, the comparison of the resulting process, the reconstruction process, and we generate the over 400 of the STL models with different parameters of the generating STL models. And we compared the every of the models with each other. For example, with the Cloud Compare software. And comparison shows us that the CT-based models, CT-based reconstruction process is much easier and faster than the MRI-based, especially due to the ability of automate this process. And the models generated based on a CT are much more accurate than the MRI-based. However, it has been shown that the MRI-based segmentation is also possible, and we can use these models when in the studies where we need the non-invasive imaging technologies. Thank you for your attention.
Good afternoon. My name is Mirela Kluza. I work at Łukasiewicz Research Network, Krakow Institute of Technology, and I am also a PhD student at Silesian University of Technology. Today I would like to present to you a poster about the analysis of the effect of the auxiliary current frequency on the patient safety in bioimpedance spectroscopy measurements. The aim of the study was to evaluate the effectiveness of the applied protection means against the low frequency currents by simulating a single fault condition in the device, by setting the operational frequency range of the device below 10 kilohertz. This situation may theoretically happen during the device failure or the cyber attack. The tests were carried out on the created measurement system, consists of the consists of the measurement circuit and the multifunctional vigilant device, which we used as the oscilloscope and the wave generator. The test scenarios were prepared in which the test measurement system was subjected to a different loads in idle mode with the 20 ohm resistor and with the patient simulated patient load according to the standard EN 6601 and 1. The obtained results are presented on the figure 2. In the device frequency operating range, that is from the 10 kilohertz, the patient's auxiliary current is below the 100 microampere, which according to the mentioned standard is totally acceptable. In the range below the 10 kilohertz, that may theoretically happen during the device failure. In the event of the device failure, the permissible values according to the standard increases to 500 microamperes, so the obtained results are also totally acceptable. Overall, the results confirm the effectiveness of the applied protection means and allow to mark the device as safe for use. Thank you very much.
Good afternoon, everyone. My name is Anna Mirok-Mirska, and I'm pleased to present Wearable Mouse project. I'm a student of biomedical engineering at the Silesian University of Technology and a member of the Biomechatronics Student Research Club Biokreatywni. Today, I would like to present results of my student internship at the Łukasiewicz Research Network, Krakow Institute of Technology branch in Zabrze. The project assumed the design of wireless computer mouse in the form of a wristband, which allows the user to control the cursor on the computer screen by rotating the wrist. The main aims of the project were to create an ergonomic user interface that would allow easy control to the mouse cursor, along with button operation, while being made of easily accessible components. Before selecting the components, a comparison of the performance of two sensors was made. The signal obtained from the two accelerometric sensors was analyzed in terms of the noise level and the reconfigurability of the sensor. After comparing the parameters of the sensor and received signals, a sensor with less noise and lower power consumption was used. During the experiments, it was noted that the optimal way to control is to use the acceleration value measured by the sensor, taking into account the range of movement the wrist when controlling the cursor. When creating the project, it was taken into account that the modification and upgrading of standard devices should be done in a way that provides intuitive operation for users accustomed to typical solutions and allows them to see the benefits of using newly designed devices. The final result was the creation of a wearable mouse. The mechanics of the device are designed to minimize the limitation of hands grasping ability when using the interface, focusing on maintaining an intuitive operation. Design device can enable and facilitate cursor control for people with some disabilities or partial paralysis of the upper limbs. Thank you for attention.
Dear audience, thank you for attending. My name is Maria Hankus, and I'm a student at the Faculty of Biomedical Engineering at the Salesian University of Technology, and I'm also a member of a student research group, Biokreatywni, based at the same faculty. Today, I would like to give you a short overview on our research on the biomechanics and ergonomics of abdominal and breast ultrasound examination. The study aimed to assess lateral flexion during mentioned medicine procedures to determine which poses are most strenuous for the diagnostician. The study involved 5 experienced ultrasonographers, 3 women and 2 men from the University Clinical Center named after Professor Gibiński in Katowice. Each participant performed the ultrasound examination using their right hand. All were healthy and reported no pain syndromes prior to the study. Approval from the bioethics committee was obtained, and all patients were informed about the study's purpose and the methodology. Kinematic data was recorded using neuraxonomia motion system consisting of 16 inertial sensors placed on the physician's body. Measurements were collected using the ultrasound examination of a liver, both breasts and both kidneys. When the data was collected, it was imported into MATLAB environment and analyzed using the custom script to assess the lateral flexion. Then the statistical analysis was performed to determine the most ergonomically challenging segments of the ultrasound examination. At the top of the screen, there is a table displaying the results of a statistical analysis, including the mean lateral flexion for each body segment, along with a bar plot visualizing those results. The analysis revealed that the most strenuous positions for the diagnostician are visible during the imaging of right kidney, left kidney, and left breast. Increased lateral flexion to the right side was visible when imaging the left kidney and left breast, as those areas were further from the diagnostician, necessitating the greater leaning to the right side. On the other hand, for the right kidney, the negative lateral flexion angle was indicated, meaning the physician was leaning to the left side because the right side of a patient's body was near the physician. Thank you for your attention.
Hello everyone, my name is Jakub Krum and I'm representing Automation for Humanity company. Subject of this presentation is an innovative comprehensive system supporting the elderly in basic daily activities, design and research with healthy volunteers. The presented study is a part of NCBR grant focused on developing the automated transfer bed as a part of an ecosystem automated care device. Conducted research aimed to assess the usability and reception of the device in a group of healthy volunteers. As you can see on the picture, here we've got the automated transfer bed with the RCTA device, which is supporting the transfer, and AGV, which is automatic wheelchair. The device is transferring the user from the bed to the wheelchair using a synchronized airbags and mechanical actuators. During the transfer process, the user doesn't need to apply any effort. We just need the caregiver to carry the remote control and assist the patient. A group of 37 healthy volunteers were asked to fill out a survey after testing the transfer. The questionnaire consisted of 3 statements evaluated by the participants. Very simple ones. So the first one, the ATB is comfortable. The second one, the transfer process was comfortable. And the third one, the device brings up negative feelings in me. In general, the results are very nice for us because all the procedures were completed. We managed to do all the transfers. You can see on the pictures our prototype of the device. The average scores obtained for the survey questions are shown in the table below. 0 was the lowest possible value, and 3 was the highest, the most positive reception. The survey results and observed transfer success score are promising prelude to implementing the presented solution in the market. They also allowed the prototype to be tested on people with mobility disabilities. So for us, in general, seniors and people using the wheelchairs. Thank you for your attention.
Hello everyone, I'm Agata Piątek.
And I'm Angelika Augustik.
And we are representing Student Scientific Association Synergia. And now we will be discussing an important aspect of cardiovascular health. As we know, cardiovascular disease are the leading cause of death globally. One of the methods for early detection is electrocardiography. However, the electrodes used in electrocardiography can cause many issues, such as allergic reactions due to the used materials. Typically, these electrodes are made from polyethylene foam and conductive gel, which are attached to the skin. And this highlights the need to explore and improve the materials for better patient safety and comfort. The main goal of our study was to evaluate the physicochemical properties of the polymer materials of which the electrodes are made. We aimed to assess whether current materials could be improved to reduce the risk of complications, particularly in terms of adhesion and skin interaction. For this study, we used 2 commonly available ECG electrodes. We performed both macroscopic and microscopic observations using optical microscope and scanning electron microscope. Additionally, FTIR analysis was performed to identify the materials used in the electrodes, and we measured the surface wettability. To simulate how the electrodes interact with human skin, we applied them to a porcine skin, which has similar properties to human. And finally, we conducted the cytotoxicity tests to determine if the electrodes had any harmful effect on the skin following ISO standards.
So microscopic observations revealed an uneven distribution of adhesive on the internal side of the electrodes. Both electrodes exhibit a hydrophobic structure. FTIR spectral analysis identified functional groups characteristic of polyethylene on the external side of the electrode and glycerol on the internal side of the electrodes. Adhesion studies and in vitro skin interaction tests revealed alterations at the electrode application sites. The cytotoxicity test for 150% dilution of the electrode glue extract number 1 showed values below 70%, which is considered to indicate cytotoxic activity. The other dilutions of both the extracts from electrode number 1 and number 2 do not exhibit cytotoxic properties. To summarize, the conducted studies revealed significant differences in the physicochemical properties of both tested electrodes. The uneven distribution of adhesive and hydrophobic nature of the surface may impact the patient's comfort. In vitro studies demonstrated that electrode number 1 causes greater skin irritations and shows cytotoxic effects in the mentioned dilutions compared to electrode number 2, which exhibited fewer skin changes and no adhesive residues. Thank you so much.
My name is Sebastian But, and 1 year ago I have a pleasure to speak here about the problem and challenges in bind mark analysis. So I'm pleased to present my research on the parameterization of dental geometric features for personal identification using the concept of biometric receipt. Before fully utilizing the whole 2.5 minutes of this presentation, I would like you to imagine a scenario where individuals have been wrongfully convinced of crimes, while bite marks left on victim could have been the only one argument to release them from prison. Currently, many courts question the accuracy of the bite mark analysis in the forensic identification. That's why this topic matters. The receipt, dental receipt concept may offer solutions to this problem. So the aim of my research is to provide a detailed description of dental geometry to improve the precision and reliability of biometric systems and identification techniques used in forensic science. For parameterization, I utilized 3D scans of the teeth, which are then analyzed using the CAD software. Examples of features that can be parameterized include more obvious ones, like 2 dimensions, length, width, height, or thickness, and proportion between them. And in that addition to these basic parameters, there are more subtle ones that may provide essentials like patterns, curvatures, or symmetry of dental arches. One such element of parameterization is, for example, the mean interpoint distance, which measures the average distance between key points of the surface of the tooth. By applying Euclidean metrics, it is possible to measure this distance in 3 dimensions. And using the coordinates of characteristic points of the surface of the tooth allows the detection of subtle correlations between the teeth, which is critical for precise identification. And these values encoded in that biometric dental receipt concept create a whole 3-dimensional model that functions similar to the golden triangle used in the facial recognition systems. With such detailed measurements, it is possible to create a unique description of each individual dentition, forming a robust and repeatable tool for identification. To sum up, in conclusion, the work on the parameterization of dental geometric features opens the new possibilities in field of personal identification. And in the next stage, of course, it is recommended to expand the data set and conduct further analysis to verify the effectiveness of this solution by applying it to the real-world cases. Thank you for your attention and your time.
Okay, so hello, my name is Michał Wisiok, and today I want to present you a research conducted by my colleagues and me, titled as Assessment of Hand Grip Strength in Correlation to Anthropometric Data for Calisthenics Practitioners. The study focuses on a physical activity called calisthenics, which is characterized by using your own body weight as a resistance. And the main purpose of this research was to explore the correlation between hand grip strength and various body parameters. Additionally, we compared two groups of sportsmen, of athletes, professionals who compete in tournaments, and amateurs who train calisthenics as their hobby or just in their free time. The research conducted, the research group conducted of 24 individuals, where 6 of them identified as professionals, and 18 of them comprised the amateur group. Based on the pre-established methodology, we measured the following values, such as grip strength in both left and right hand, body composition, pressure distribution in open hand, and anthropometric measurements. After collecting all the data, our team was able to illustrate the correlation and result using charts. So, talking about the charts, the first one on the left shows a positive correlation between arm circumference and grip strength, indicating that people with larger arm circumference tend to have greater grip strength. The regression line, the black one, highlights overall upward trend. The second chart on the right compares the anthropometric data and dynamometric data of amateur and professional calisthenics athletes. Professional ones with darker bars clearly outperform amateurs, while lighter bars, which are for amateur, their parameters are lower than the professional ones. And grip strength and values in particular show a clear advantage for the professional group. So based on these two charts, we conclude that the professional calisthenics athletes demonstrate superior strength, performance, and slightly larger anthropometric measurements compared to amateurs, which is typical for more intense training and greater experience. Thank you for your attention.
Good morning, everyone. My name is Łukasz Gołeczka, and today I'll be speaking about part of my doctorate. So, automation of hardness measurement and 3D modeling in generative or 4M hardness map. Background of this research is pretty complex because nowadays we see much more generative diseases like diabetes and cancer. Normally, when we study the development of data from NFZ, sorry for my voice, we see increasing rate of the amputation. Aim of this study was to conduct a program that will create automatically generated stamp covers for each and every one patient that will be measuring materials and methods were relatively simple in a way. I used Rhino 3D CAD to not design but program the whole process of getting the data, cutting them into parts, and working with the G-code created by the program. Normally, I used normally the results were relatively complex in a way. Overall, I created a program that can automatically conduct 3D G-code lines, add the structure onto the outer layer, and in a way add hardness map onto the program itself by continuously pressing the linear motor onto the object that we are measuring itself, and then creating the model itself. So in conclusion, the method provides a more effective way of complex topic, that is methodology of creating a silicon socket. Thank you very much for your attention.
Hello, my name is Zbigniew Dostrowski. I represent today Hemolens Diagnostics company, startup that is, we try to develop diagnostic tools in cardiology. As you already heard in this room today, there is almost 20 million of deaths annually worldwide on coronary artery disease. And the spending on that cardiovascular disease costs is high, and it's rising, and it's anticipated to be even larger. So there is a screening challenge. We try to fill that gap. The mission is to provide the technological support for personalized medicine, for personalized, accurate diagnostic, non-invasive one. And we believe that the technology will help us to achieve that goal. The company and the products are based on three main legs, we can say. We are using AI for segmentation, for example, of images, and we are using the biomedical engineering in general to obtain patient-specific data tailored for this particular patient during diagnosis, and computational fluid dynamics, the tools that the opening lecture was about, to simulate the flows of the blood. What are the goals of the company? There is a series of products that will fit into the cardiovascular diagnosis. Starting from CardioLens FFR CT Pro, which was anticipated in 1.5 years on the market. That is the non-invasive fractional flow reserve estimation or diagnosis from CT images. There is this year the early first part of the product will come to will be available, which is a viewer, a kind of tool that will allow cardiologists to easier interpret the cardiac CT data. And the target is the full platform that will have several points, several products available, and it's coming in coming years, let's say. What's the conclusion? According to the last month European Society of Cardiology guidelines, the role of cardiovascular CT scans will increase. It is identified as a selection of the tests for the patients with suspected of coronary artery disease, and for also the FFR CT, which is the this non-invasive one, is also considered in those guidelines. So that's what I wanted to show you today. Hope we can meet one day or in a hospitals with the doctors, but also with the students in the company. Thank you.
Good afternoon. My name is Jan Mucha. I work in the Łukasiewicz Research Network, Kraków Institute of Technology, Biomedical Engineering Center in Zabrze. I would like to present a work which title you can see behind me on the slide. Ablation is the standard method used to destroy tissue in medicine therapy, in particular in oncology therapy to destroying cancer tissue. The most common is thermal ablation, which use high, for example, radiofrequency ablation, or low, for example, cryoablation temperature. The temperature destroys the tissue. There also are methods, non-thermal methods ablation. For example, irreversible electroporation. Electroporation involves acting on cells with short series of high voltage pulses. These result in the formation of pores in the cell membranes. Aim of the study is to determine the range of time and amplitude parameters for pulses generated by an electroporator dedicated to research in cancer therapy. A literature review was carried out. Circa about we reviewed 1,000 items on which the pulses parameters were determined in wide range of application in oncology therapy for different cancer tissue types. The most important parameters are pulse shape. We decide to use simple rectangular pulse phase and amplitude, number and frequency of pulses, number and time between packages of pulses. At the bottom of the slide, you can see the basic pulses parameters definition. In the next slide, you can see the value of these basic parameters which have been determined. These parameters are adopted as design requirements for our electroporator devices. Now a pulse generator is currently being developed. Moreover, the developed electroporator must meet all requirements for medical device. Thanks for your attention.
The next speaker is Grzegorz Nowak.
Ladies and gentlemen, my name is Grzegorz Nowak. I am a researcher at the Center of Biomedical Engineering in Łukasiewicz Research Network, Kraków Institute of Technology in Zabrze. Today I would like to present the current research results about applicators for tissue ablation by irreversible electroporation method in oncology therapy. I would like to point out that cancers are among the major diseases of the 21st century, with both genetic and environmental factors increasingly linked to lifestyle. It is the second leading cause of premature death after cardiovascular diseases. The World Health Organization predicts a significant increase in cancer cases globally, making the development of new therapies critical. One of the newest method is tissue ablation through irreversible electroporation. It is a method. This method uses short, high voltage pulses to damage the cell membranes. Pores form the membrane, and the cell undergo apoptosis. It's a natural controlled process of cell death. The body immune system removes then the cell remnants. And an electroporator generates the high voltage pulses, which are delivered to the tissue via applicators. However, modern surgical tools and devices are needed to bring this method into clinical use. The study aims to design optimal applicator for electroporation, focusing on their shape and materials. Development of these applicators will allow for preclinical animal trials and later for clinical studies. The studies will help optimize the oncology treatments using irreversible electroporation. The study reviewed thermal ablation applicators used in oncology, examining their construction and design. From this analysis, key parameters like length, diameter, and shape were established. This will serve as design guidelines for creating electroporation applicators for research in cancer therapies. Thank you very much for your attention.
Hello everyone. My name is Imre Simon. I'm a colleague of the PT 3D Printing and Visualization Center at the University of Pécs in Hungary. There is a growing demand for electrically conductive, flexible, non-corrosive materials, particularly in medical applications. This study highlights the significance of conductive polymer composites in additive manufacturing. It aims to investigate the mechanical and electrical properties of specimens printed with the material extrusion method from conductive filaments, focusing on their potential use in medical sensors. A total of 64 specimens were printed from ESD-ABS and ESD-TPU materials. These specimens were subjected to mechanical testing in accordance with ISO standards and electrical property evaluation. Resistance temperature measurements were conducted using an Arduino Uno and a heated print bed to assess how resistance varies with temperature changes. Resistance measurements during 3-point bending test were designed to ensure that the conductive polymer remained in the bending zone, allowing for accurate assessment of electrical properties and an understanding of the relationship between resistance and flexural angle. ESD-ABS specimens had a tensile strength of approximately 20 megapascals, which was higher than that of ESD-TPU specimens, which was approximately 5 megapascals. The elongation of the ESD-ABS specimens was about 2%, which was less than that of ESD TPU specimens, which was about 30%. The resistance temperature measurements indicate that the materials exhibit different resistance characteristics at varying temperatures, which is important for thermal sensor applications. The resistance measurement during the 3-point bending test showed that for the ESD ABS specimens, the resistance was linearly increasing between 8 degrees and 18 degrees of flexural angle. The study concludes that ESD ABS and ESD TPU composites are suitable for low voltage medical sensors with specific applications in bending deformation and temperature sensing. Thank you very much.
Good afternoon. My name is Maciej Domik. I am neurological physiotherapist from Technomex company, and I want to present a systematic review about robotic solution use in neurological rehabilitation, focus on technologies such as end effector systems and exoskeleton robots. End effector system is a stationary robot in which distal part of patient's limbs are attached to the device, while exoskeleton enables patients to cover some distance, for example, on corridor or outside even. Researchers often take both of this robotic solution and call the therapy on it as robotic assisted gait therapy. And our goal was finding and detailing all the benefits of using robot-assisted gait therapy for different neurological patients, spotted in quality scientific researches. The patient was after stroke, after spinal cord injuries, cerebral palsy, or multiple sclerosis. Here are the inclusion criteria. Year of publishing since 2017. And here are some of the benefits for the neurological patients. First and foremost, significant improvement in gait velocity, balance, maximum walking distance, and overall walking parameters. Second, the enhancement of trunk muscle activity and seated postural control. Also, improvement in body posture and potentially bone health. And what was also spotted was using robot-assisted gait therapy was generally associated with at least moderate level of physical activity, which may have cardiorespiratory health benefits according to World Human Organization guidelines. And the conclusion are end effector and exoskeleton robots can not only improve functions connected with gait, but also several different important positions. And researchers report on the need to tailor therapy to specific disease and, what is more important, to functional problem of the patient. And there is also a call for long-term effect studies to fully understand the benefits of using robot-assisted gait therapy for neurological and other patients. Thank you for your attention.
Ladies and gentlemen, my name is Łukasz Mazurkiewicz. Together with our team from Military University of Technology, in cooperation with medical guys from Medical University of Warsaw, we deal with brain vessels and its frequent pathology, which is cerebral aneurysms. We focused on the flow diverter stents, which are the one of the treatment methods for this disease. Those flow diverter stents are desired to divert the flow to main artery and prevent the blood flow to the pathological volume, reduce the flow to that volume. So we focused on the mechanical behavior of that stent. We performed the stent model based on beam elements with all the cross-section parameters included into the contact with vessel walls. The hard part was to represent the interaction between many wires interacting each other, comparing to the standard stents, which are cut from the laser cut from the tube. In that case, it is much easier. So we reproduce that interaction using locally directed kinematic constraints and obtain the proper behavior of the implant. So you can see the expansion process of the flow diverter stent and the validation comparison between the simulation results and the experimental results. We compare the porosity and the font shape of the stent. The next stage was implantation of that stent into the artery 3D model. So in the next picture, you can see the one stage of the expansion process of the flow diverter stent. As a result of that simulation, we were able to obtain the final geometry of the flow diverter stent after the expansion and use it for further CFD analysis to estimate how much the flow diverter stent can block the flow to the branches, to the perforations from the main artery. Thank you very much.
Hello everyone, my name is Joanna Karpiel and I represent Łukasiewicz Research Network, Kraków Institute of Technology in Zabrze. I briefly speak about introduction. Air pollution is an increasingly more issue, especially in urban areas around the world. It has a significant impact not only on health but also on physical performance, particularly for athletes. The city of Kraków, like many other large cities, faces challenges related to monitoring and improving air quality. Pollutants such as sulfur dioxide, particulate matter, and nitrogen dioxide often exceed acceptable levels, which can significantly affect respiratory health, especially for individuals engaged in intense physical activities like running. In our study, we aim to examine how environmental parameters, including air pollution, levels affect athletes' performance. We use a portable device to measure pollutants and technology that monitors the runner's respiratory functions, such as breathing rate and tidal volume. This allowed us to track both environmental parameters and the physiological responses of the runner during training in various conditions. In the picture, we see example road map of a person running around Kraków, and the second figure presents our device and application for mobile phone. Here we see two features. On the left, environmental parameters during one of the tests, and on the right, respiratory signal recorded under decreased environmental quality condition. On the right, present more frequent, deeper breaths when environmental conditions deteriorate. The comparative graphs analyzed also show similar correlation, with the maximum amplitude of the change in parameters increasing from 2 liters to 3 liters in the fragments analyzed. This situation may be related to the increased oxygen demand or a direct result of the polluted air composition. In short conclusion, the study highlights the significant impact of air pollution on athlete efficiency, focusing on the respiratory function of runners in an urban environment such as Krakow. It was noted that higher levels of pollutants correlate with deeper breaths and changes in respiratory parameters, suggesting the body's adaptation to changes in air quality. Thank you very much.
Good afternoon, everyone. We are students of the Synergy Scientific Club, and thanks to the support of the Initiative of Excellence Research University Program, we had the opportunity to carry out a project, the effect of a cigarette smoke on changes of the physiochemical properties of surface on biomaterial used in dentistry.
In our project, we use samples made from Imprimo LC denture acrylic resin printed using the Asiga Max 3D printer. We constructed a testing setup in which the samples were attached to the lid of the beaker, which contained the liquid with substances from e-cigarette smoke. The proportion of substances in the liquid simulated the effect of burning 1,000 cigarettes. And then the entire system was heated to 280 degrees and maintained at that temperature for 1 hour.
As a result, we obtained that these samples had comparable roughness before and after exposure to smoke. In a few places, the surface took on a yellowish shade and cracked, probably due to the high temperature. The abrasiveness before and after exposure varies, but the differences are probably due to the effect of the temperature rather than the chemicals.
The conducted research didn't show the clear effects of substance found to tobacco smoke on the qualities of the tested material. It would be necessary to make temperature-limited tests to determine clearly the effects of the substance on the acrylic material. Thank you for your attention.
Dear audience, my name is Wojtek Pieniążek. I am student of biomedical engineering at Silesian University of Technology's Biomedical Engineering Faculty and a member of Scientific Club Biokreatywni. Aim of my speech today is to briefly introduce you to our research on analyzes the segmental body acceleration and its impact on both accuracy and repeatability with both long and short firearms. Our study was conducted on a group of 20 people aged 18 to 50, divided into 2 equal groups, one containing 10 professional shooters and one with amateurs, who were asked to take 10 shots with a handgun at a distance of approximately 10 meters and 10 shots using rifle at a distance of 20 meters. When they shot, the myomotion Noraxon inertial sensors placed on participants' hands, C7 vertebrae and T12 vertebrae and pelvis gathered data about the acceleration of body segment they were placed on. In order to determine participants' accuracy and repeatability, the shooting targets were scanned and analyzed in MATLAB environment. Using our developed algorithm, we could calculate a circle circumscribed by the marker hits on the target. And because of this knowledge, we could define accuracy as the distance from the center of the target to the center of the circle, and repeatability as the circle's radius. If someone, for example, hit 9 shots into the target and missed one penalty shot was added at the verge of the shooting target at the shortest possible distance from the circle we calculated. Recorded acceleration of crucial body segments were later compared to each shooter's repeatability and accuracy and visualized as scatter plots. 2 of them you can actually see on the screen. One depicts the dependence of acceleration of right hand to repeatability, and the second is about C7 vertebrae. All the results are pretty much the same for both long and short firearm, and they indicate one thing, and that is that with less hand acceleration and higher torso acceleration comes not only better accuracy but also better repeatability. This may stem from that professional shooters tend to counter-react to the recoil by moving their torso, while the less advanced contestants usually counter-reacted recoil by moving their hands, which is not correct. Thank you very much.
Good afternoon. My name is Mariusz Sobie, and I am representing Łukasiewicz Research Network, Kraków Institute of Technology. Today, I would like to present the first stage of our ongoing project titled Bedside Assistive Manipulator. The main subject of the project is a manipulator designed to assist people who are temporarily immobilized and spend many days in bed. It is planned to be implemented as a part of a bigger project of a mobile assistive platform. This platform, besides the manipulator part, will have additional modules such as interactive modules, enabling the communication along with determining the mental state of the patient, and diagnostic models measuring health factors including the body temperature, heart rate, blood pressure, or glucose level. And the final version of the platform will also have the ability to move. The aim of the study was divided into several parts: literature and market review, brainstorming and making assumption, creating a general concept of the manipulator, and designing and construction a prototype, then verifying and validating the physical model. Literature review show as that the most of the existing assistive manipulator are surgical helpers like Da Vinci robot or feeding robot like Obi and My Spoon. 2 non-commercial projects of other type have been found. Those manipulators were both designed to help a mobile patient in their daily lives. They execute simple handling tasks around the closest area. The 2 mentioned robots are PR2 robots designed by Willow Garage, which works in collaboration with an automatic bed called AutoBed, and Ellie robots designed by students from Georgia Tech University and Emory School of Medicine. The slide showed the manipulator segments size needed to easily reach link humans' limbs and the borders of the bed. It also shows the height of the robot base and its distance from the bed for the robot to operate well without any collisions. We came to conclusion that this project has a potential to continue in the future as a part of the second project and initiate the creation of a prototype of a future medical device. There are not many assistive manipulators available on the market, and there is clearly a need for a solution that could be used by any individual. Thank you for your attention.
The next speaker will be Agnieszka Antończyk.
It will be short, I promise. Good afternoon, my name is Agnieszka Antończyk and I'm a PhD student in Zabrze University of Technology, exactly in Faculty of Biomedical Engineering. Today I would like to present my research, exactly it's an evaluation of mechanical properties of bone cement with polymer-based spherical aluminosilicates. So that we know our situation is age, so we have a lot of information about the fracture bones, implants, and we need some solution. And one of these solutions is bone cement. So current bone cement is have very disadvantages because not have a good mechanical properties. Have a during the polymerization, the temperature is increased to a very high amount, and of course have residual monomer. So I decided to create new type of bone cements with spherical aluminosilicates. What is this aluminosilical silicates? So this is very interesting materials. It seems to ceramics, but it has spherical shapes, and it's seems to be empty inside, but it's not empty. It's gas inside. So I combined with polymer matrix. But the first I changed some process because I functionalized this material. The first I carried out sterilization process using a silicon nitrate with sodium hydroxide to create a good a good chemical combined with matrix. So how it looked like? In here we have filler, aluminum silicates, then we have matrix, and the third thing is about how it looks each other. So after I check how it looked like with hydroxyapatite, and then I check the mechanical properties. I use a static 3-point painting test. So we see to increase the filler, the modulus is higher, so it's more hard, but it's bright. So aluminum silicates can be used in biomedical engineering, for example, to bond cement, but to increase the mechanical properties, we should change the matrix. Thank you very much.
And the last but not least speaker is Kinga Cardos.
Dear audience, my name is Kinga Kardas, and I'm a researcher at the 3D Printing and Visualization Center at the University of Pécs, Hungary. And I would like to present our research work on 3D printed polylactic acid composite materials. As a background, recently the 3D printed polylactic acid-based composite materials has the interesting area of research. This is not surprising because PLA is easily printable biocompatible material which is widely available, and it can combine with metals, for example copper, which has antibacterial properties. The aim of the study was to perform mechanical comparison about two commercially available polylactic acid copper polymer composite and compared to pure PLA. We used two composite material from Protopesta and from Futura material, and we prepared the specimen with fused filament fabrication technology, and after that we perform a series of mechanical tests according to ISO standards and scanning electron microscopy and thermal conductivity measurement. I would like to highlight the tensile test from the mechanical test. The results show that the tensile strength of the Form Futura classic copper material was significantly lower than pure PLA, but the tensile modulus of this material was similar to pure PLA. The scanning electron microscopic images show the presence of copper particles, especially in the Form Futura material, and they are less visible in the Protopesta material, but in this material the layer fusion was poor. The thermal conductivity factor of the two materials was similar. They were about 0.1617 watt per meter per Kelvin at 47 degrees. In conclusion, the PLA copper composites have a similar thermal conductivity factor, but the mechanical properties were different, so they can use in different medical solutions. In addition, the Form Futura classic copper material can co-print with pure PLA, which can open new possibilities in medical device development. Thank you for your attention.
So thank you very much for your attention. Thank you very much for very interesting presentation. The final score of the competition of representation will be announced tomorrow at 3 p.m. at the final ceremony of this conference. Thank you and have a good day.